Hello students, the question is, in a double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minima formed on a screen placed 1 meter away was found to be 0.2 degree. What will be the angular width of the first minima if the entire experimental apparatus is immersed in water, given mu of water is 4 by 3. The options are given. I write the formula for the angular width of the first minima or first dark formed on a screen. Let's see what is that. We know in YDSE the fringe pattern looks like this. The fringe pattern looks like this. This is the screen. Suppose this is the central bright fringe. This position is the first minima or first dark. This is also first dark on the other side. This is first bright or maxima, you can say, on one side, and this is second bright or second maxima on the other side. Now they ask you the angular width of the first minima. Now the angle, what about the angular width? Angular width is this. Suppose this is theta 1, this is also theta 1. Now we know that the distance of the first dark from the central bright fringe is given by, let's write the general formula first. Distance, that is the linear distance of the nth dark fringe from the central bright fringe is given by xn equals to d into 2n minus 1 lambda over 2d, and we know capital D is the distance between the slit and the screen, small d is the distance between the two slits, lambda is the wavelength. So xn is the linear distance of the nth dark fringe from the central bright fringe. Therefore I can say when n equals to 1, that is the first minima or first dark or first minima, we can say the linear distance is d into, putting n equals to 1 here, d lambda by 2d. Right or wrong? So this is x1. Therefore I can say the angular position of the first minima will be sine theta 1. If it is very small, I can replace it by theta 1, which is equals to x1 divided by capital D. So the formula is lambda by 2d. Now this is the angular position of the first dark with respect to the central bright fringe. Now if they ask you angular width, so it means this total angle. So the angular width of first minima will certainly be 2 theta 1, which is lambda by small d. Now that's the formula. That's the formula of angular width of first minima. Okay. Now coming to this problem. Now initially it is given that the angular width of the first minima is 0.2 degree. Mind it, this is the value when the experiment is performed in year. But when the entire apparatus is immersed in water, what will happen? See, look at the formula lambda by d very carefully. In this formula, this small d was what? Small d is the distance between the two slits. Now small d cannot change uh, when the experiment or the YDSE is performed inside water. It has a fixed value, small d has a fixed value, but lambda, wavelength of the light, a light which has a wavelength lambda in air will have certainly different wavelength when in some other medium, and the formula for that is, always remember, lambda 1 divided by lambda 2 equals to V1 divided by V2 equals to mu 2 divided by mu 1. So lambda varies inversely to refractive index. Now, if a light has wavelength lambda in air, what will be its wavelength in water? So lambda air divided by lambda water equals to mu of water divided by mu of air. What is mu of water? Mu of water is given in this question as 4 by 3. Mu of air is 1. Therefore, I can say lambda inside water is 3/4 times the lambda in air. Therefore, I can say the new angular width, will be, see the formula, lambda by d. So new angular width will be lambda water divided by d, that is 3/4 of lambda air divided by d. Lambda air divided by d is given as 0.2 degree. So the answer is very simple, 0.15 degree. I hope you understand. So option 4 is correct. Thank you for watching this video. Please subscribe my channel, Phi Solver.